Hello everyone. So, today, and I will make sure my mic is working, yes it is. Today, I am in my hopefully to be permanent location in the new apartment, but this is a temporary orientation because currently the room is not set up. I've just made some space and there happens to be a table in here, so don't get used to this specific view. I will eventually be over here and there will be a desk of sorts that's less makeshift. But at the moment, I have the room to myself, so even if anyone comes home in the middle of the stream, which I'm not expecting at all, I should be pretty good to go. So today, I did mention on Facebook that there might be a mystery topic. I wasn't able to actually come up with one, and I didn't want to force anything just because that tends to not be good content in general. So today, I'm just going to have a little bit more discussion on my data mining project, and then after that, we'll go into my random drawing section. So, but that's pretty much the game plan. If there's any general questions or any ideas of something I can talk about just randomly, please post them in the chat. I'm very open to it because I don't think that I have a full hour's worth of content for today. So if you guys want me to keep talking and you have questions, I'll be very open to answering them. But if that's not the case, then we'll just end this a little early and we'll move on, and I'll hopefully have some topics ready for next weekend. But with that being said, I am going to move into my first topic, which is just another discussion about the data mining project. So I'm going to play a quick ad here while I get some stuff together, and I'll be right back. Okay, sorry about the wait, and I think we're back from the commercial. So, my first topic is just the discussion about the data mining project. So, if you came on the stream on Wednesday or watched the video after it was uploaded, you'll know that I've been working a little bit more on the data mining project. And since Wednesday, I've done a little bit more on it as well. But there's been some changes in my state of mind in terms of how I plan to tackle this task. Originally, I was thinking that I would need to completely just trash what I had done before, and not necessarily trash it, but just go through and rework each individual piece. And although I am still planning to do that, I am keeping a lot of the code that I was originally using for previous deep learning projects. So what's different is obviously there's some big changes in how the data mining project works, and one of the big ones is how the DNA files are set up. So previously, I would have a randomly created DNA file that is not necessarily completely random. It's random based off of a set of parents, and those parent files, which are considered the better of the previous generations, would provide two possible options. And so of those two possible options, one of them would be randomly chosen based off of a weighting, off of the scores of the two parents. And then there'd also be a random possibility of a random mutation. Now, this worked very easily because the entire structure of the DNA files were completely stagnant. They were always, in the case of the previous project I was working on, they were always 1,250 different numbers, and so that meant that when I went in and made a random selection for a given mutation, I could. It was pretty easy because there was no changing in the size of the actual file. Now this is something that's changing because in the previous stream I said that I wanted to make the actual AI a little bit more dynamic, and the way I'm doing that is I'm giving it free reign on how big of an answer it wants to create. Now this could become problematic, but I'm planning to also add in some precautions so that it doesn't run on forever, because I think this is going to be something that can be completely run to exhaustion or to tolerance in the case of this in one day, perhaps even in a couple hours, maybe even shorter than that. I'm open to be surprised by this, but I don't think this will be the day upon day running that the ball drop or the environment project was. So I think this one will be a little bit simpler, and because of that, I'm working it into being a little bit more dynamic. And so by dynamic, I mean that the actual structures of the data themselves can be resized as the AI requires it. And so I'm going to pull up a paint screen here and just kind of explain this a little bit. So previously, I would have a file and it would just have a bunch of numbers. So you'd have like a 1, 0, 2, 164, 7, 3, 5. And this would just keep going on. And these numbers were specific to individual characteristics of an if statement. Now, if you don't know what an if statement is, I would suggest either just looking it up on the internet, or I have given a brief description of it on a previous stream. But basically what it is it's a conditional statement used in programming. So pretty much any programming language has an if statement structure because it allows for dynamic programs. So if a specific condition is seen, then the program follows a different path than if it were if the condition is not seen. And so there's some extra bits here and there about special kinds of ifs, but that's the general concept. So that was the idea that I was basing the entire program on. The AI would create if statements that would be the instruction manual per se for the task it's attempting to play. But this is a different task because it's not a game. This isn't something where if I just turned it on by itself, it would run even though it's not being given any instructions. So this is something where I provide the program with some data, and it provides me with an algorithm for replicating a specific variable. And so I've talked a lot about this on the big data. Big data stream. I've talked about this on previous streams about the data mining project. But what this is basically doing is, instead of creating if statements, so this is if, there's going to be individual pieces of an equation. So you'll have, let's say you had blank, or here, well, let's put some variables in here. A plus B minus C. This has 3 different pieces of the puzzle, and this will equal some answer Z, I don't know. So we have this piece, we have this piece, and we have this piece. Now, these pieces can be broken down into individual sub-pieces or subparts, because this A, which is a variable, may be dependent upon other variables. So let's say this A breaks down into x plus y over q, and this B could be m times times n, and I don't know why that's uppercase, so n. And maybe this is just its own thing. But as you can see, each individual piece can have a different size than its next door neighbor. So this C would be pretty simple because maybe this is just one of the input variables. But this B has two variables within it, and these variables could be split up again. And A has three variables, and these variables could be split up again. So you can see what I'm saying is that the if the AI wants to create a correct representation of the variables or of the pieces of the puzzle and then put them all together, it needs to create small equations within the big equation in order to get the whole picture. And so this is why if you actually remember the equation from the previous stream, or the equation that I've shown for the data mining project that I plan to use as a test for the data mining project once I feel it is up to the job, it actually is one huge fraction with many little pieces in here and operators in between. So this would be something like A equals Z, and this A is actually broken down into a bunch of different pieces, which are broken down into even smaller pieces. So it's very complex, and that's why I think it's a pretty good task for the AI to attempt to accomplish. Now, I do plan to try simpler equations, probably something as simple as this with no dynamic stuff going on, just to make sure that the algorithm I have written is running properly. But this is the end goal, to have this huge, very complex fraction and see if the AI can at least approximate it through many pieces or actually get down to the correct answer. So that's what's going on with the data mining project, but you will remember if you've seen the previous stream that I was planning to somewhat restructure how the I had individual pieces that the AI could create. Now, I realized that this was somewhat redundant because when I created my deep learning algorithm or the adjustments to the previous neural network to make it more deep learning oriented, I created I changed how the variables are handled because so what I did in the deep learning algorithm or the deep learning changes is I had so we had our original variables, and I've explained this a couple times, but I'll go over it again because it's pretty straightforward. So I have the original input variables. Now these input variables are trying to explain some variable, I don't know, A. And so we have X, Y, and Z, and the network, the neural network, is trying to explain A using these three inputs. Now, perhaps a random linear combination of these three inputs will completely explain A. But usually that's not the case. In life, there's a lot of dependencies, and even in the situations where there's not, we're usually making assumptions. A lot of physics-based and other things that have equations that are seemingly linear and independent with their variables, they aren't. They're usually approximations, and there's something going on behind the scenes. So what the deep learning algorithm does is it takes the input variables, and it just tries out different dependencies. So what it could do is maybe it would create some variable that's 3x plus z, and it would actually no, that's not a good idea. Let's say it's 3x y divided by z. And so this in itself is an equation, but then this specific equation could be added into this linear combination with the input variables to create the answer A. So this is what deep learning does. It creates new variables that are complex, and it creates new levels. So this would be a second level, whereas these are on the first level. And perhaps once the deep learning algorithm keeps going, it could take this variable and throw it, let's call this one q, and it could throw this in with the previous input variable. So maybe xq over zy is a tier 3 variable. And so you get the idea. It constantly creates new levels of variables, and so that's why it has this deep aspect. But what the benefit of this is that it can actually create very complex equations simply by creating new variables that are combinations of the equation of the previous variables that it has to work with. And so I was saying in the previous stream that the Lagrange interpolator could be pretty easily created through the deep learning algorithm, because it's just like x minus some constant over some constant minus some other constant. And actually that doesn't make sense. It's this way. But you get what I'm saying. So this is not too complex of an idea. These are all just numbers, and then this is one variable. And so what this does is it actually can be a switch, so it will turn on when the value is this, but it will turn off when the value is this. And so I've explained this whole idea in a previous stream. But what I was saying is that I was thinking of using this as an asset for the AI, but I thought that it was actually pretty easy for the AI to create on its own. And because there were similar things that weren't necessarily Lagrange interpolators, because they were like x minus y over x plus y, this has the same basic concept, and the deep learning algorithm can create this on its own. So what I plan to do now is to actually incorporate more operators into the deep learning mutations. So what I have included is so what we had previously was plus, minus, multiply, and divide. And so, I'll make that a little bit more divide-y, because it kind of looks like a slash mark. Okay, so these were what we were working with before, and the AI could create combinations of variables using these. Now, what happened a lot of the time was it would create variables that would then have zeros on the denominator, and they would not work out. What I did was I just simply I said that if a error occurs because it is trying to divide by 0, then just throw that variable out. So what happened was the fitness score was completely dropped, and the variable was of no use, because for what I was working with, there was no reason to divide by to even like get close to dividing by 0. There was no reason to approach that limit. So so this is what we were working with before. What I've added in is the power function, and this is a function that's listed in Python, but what it is it's just x to the y. So what I did was I said it can take what has been previously created, and it can put another variable as the power of that variable, and then that's now what we're working with. And then I also added in cosine. Now, I am still tossing cosine around in my head because this is not necessarily an operator between variables. This would be a mutation of a variable that is already existing. But that doesn't necessarily mean it's not important, because cosine is something that shows up a lot. Also, I'm planning to add in the constants pi and e, because pi and e also tend to show up a lot, and if there's something that needs to be explained by e to the x, then it will be able to create that by first including e and then using the power function. Sorry about that. So with these extra additions, I think that the AI, through deep learning, will simply be able to achieve the equation that we are hoping, or any equation, because that's the idea. This is supposed to be a general algorithm. So that's the idea of what's going on with the data mining project. I have made a little bit more progress on it, but I did have one instance where where my IDLE crashed and I had to redo what I was working on. It was more of organizational stuff, so I was kind of scanning through my previously written code and deciding what needs to be changed for the new project. It was most of the functions and most of what's going on in the code, but the idea is the general structure is already there, so I think I should use it. So that is my whole discussion for the data mining project. If there's any questions about that, you can post those in the chat. I'll try to answer them. If not now, I'll answer them at the end of the stream. But for now, I am going to play a quick ad, and we'll move into my random drawing section, which I've done for the entirety of this show. So you have that to look forward to, but I will be right back. Hello. Okay, I believe we're back. So I have my random number generator up on my calculator, and I have my sheet of random words. Now, if you haven't seen this section before, basically what's happening is there are 25 nouns, there are 25 verbs, and there are 25 adjusters, so adjectives or adverbs. And so I'm going to pick 3 random numbers, starting with 7, which is a rectangle. We're going pretty simple today. We'll pick another one, which is 1, which is sit. I'm not sure. I think we actually had that on the previous one. Yes, so I can see from a previous comment that it was sit. So we'll go with a new one that's 24. So that is print. And we have our third number, which is for the adjuster, and that is 21. And we have thin. So we have rectangle, print, and thin. So we have to decide what order these are going in. Is the rectangle being printed in a thin way? Is there a thin rectangle that's printing something else? But I think that it'd probably be easier to go with the concept of the rectangle itself being printed. Or perhaps it's something that is going to be used to be printed to print something else later, but it's a thin rectangle. So maybe we can work with that. So we'll get some 3-dimension in here so that we know that it is a thin rectangle, but we are working. So that in itself is a pretty thin rectangle, but we should also make the three-dimensional prism somewhat of a thin rectangle in all regards. So this is the three-dimensional prism made up of thin rectangles. Now, I would guess a thin rectangle would be under a 2-to-1 ratio, so less than a 2-to-1. Well, actually, this would not make sense. So we need the 2. It is a 2+to1 ratio. So this would mean that it is at least 2-to-1, because we want the length of this rectangle to be much longer. So this will be L, and this would be W, and this would be, let's say, H. That's pretty normal. So we want L to be much greater than W, and we want W to be much greater than H. And then H is the final dimension, considering it is three-dimensional. So these are our terms to live by, but we also have to get into the actions of this. So we have a thin rectangle here. It is actually a thin rectangular prism made up of thin rectangles. And so this prism is actually going to be printing something. And so we have to first decide what it could be printing. But, we can just kind of go on the idea that we've already gone through. So we can actually have this rectangle print subsequential thin and thinner rectangles within it. So if we can imagine that this is actually a block of rubber or some sort of squishy material that can be somewhat malleable or at least carvable. Because if you actually have a block of such material, you can take a sharp object to it, and you can actually gouge out individual pieces, and then if you were to run it through some ink and press it to a paper, you would be able to draw out a design. So maybe we are going to color this in a little bit darker, and this as well. And so we have this color scheme we're working with, and we'll continue this on throughout the rest of the prism. But we can actually maybe just say that this is a stamp in general. So if we grab our outliner, we could have some sort of handle, and then this handle itself would be three-dimensional, and we're going to have to work with the angles a little bit. So I'm not sure that I'm staying true to my perspective, but we'll try and work with what we've got. This would actually have to go straight down, so there we go. That looks about right. And we can get some perspective going to where it actually seems to get smaller over time as it goes down the page, or at least stretched out. And so now I have continued my failure to complete shapes as I have in the past. This is a common blunder of mine. If you look at previous drawings that I have done, so now we have our complete picture, which is now completely maroon, but I think that should do it. So we now have a stamp. If this is applied with some velocity v and some and then it has in its core some mass m, there is no changing to that mass due to the fact that it is a solid object, and we have previously gouged out these ruts. Then we can take perhaps a notepad and we can draw that out, and this notepad would have some blue lines on it if it were just regular notebook paper. But perhaps we've used some red ink, so what you will see is the ink will actually imprint what the convex shapes are. So convex being outwards, so this would be convex, and this would be concave. So the concave shapes will not show up, and the convex portions of the stamp will show up, so we will actually get a shape that looks somewhat like this. Now, usually when you do a stamp, what will happen is if you don't have the correct proportion of ink, the ink will actually leak into the concave sections of the stamped image, and so it won't be perfect, but I'm assuming that my imperfect line drawing will actually give that impression on its own. So we can color this in, and so we are getting this red image on our lined piece of paper because it is a thin rectangle made up of thin and thinner rectangles within, but we have, as humans do, made this into a tool for our disposal to print this somewhat door-like image on a piece of paper as we please. Now, if this is a hobby of yours that you enact in your leisure, then you will be very satisfied with the result. Now, I don't know that the sizing is to scale, but perhaps you can use this as a determination of how far this this stamp is from the actual paper through the distance d. If anyone wants to make an estimate of what that is, I am open to suggestions. But judging by the ratio, this is about a 1 to 1.75. I know that's improper, so 1.75 would multiply by 2 to be 3.5, and then multiply again by 2 to be 7. So if we multiply 1, that's 4 to 7. That's a 4 to 7 ratio. So if we are assuming that this point is where the stamp begins to go into the screen for us, then we can assume that perhaps this distance here is 7 units to this distance 4 units. And so I can tell you that the pixel here is 529 263, here is 596 363, and here is 685 476. So if anyone wants to do the math based off of the size of a pixel, be my guest. I do not, so I am going to approximate this to be about 3 centimeters. So that would be, if this is 4, then this would be 21 over 4 centimeters away from this point in a straight line. So I think that we have a pretty complete picture here, and so I want to thank you guys for watching. If you have been keeping up to date on the stream, I want to thank you guys for being loyal, and I know that I have a couple friends that come on the stream now and then, and some that actually try to catch all of them. But please let anybody know if you think they'd be interested in what I'm doing here. I should be back to a pretty consistent schedule now that I have this set up the way I do. So once again, thank you guys for watching, and I will be seeing you on Wednesday.